more limits with algebra this time. As we do algebraic limits, there's a lot of different methods. One of the first methods that you should always try, always, is direct substitution. Try just plugging in the number. Example 1, plug in 4. Square root of 4 is 2. 4 squared, 16. So we get 1/8. Okay. Cosecant of 5/3 pi. That's something that you should be able to do. Okay. So if you need to, you know your 3, 2, 1, 1, 2, 3 thing. Okay. All of your special angles. 5/3. All students take calculus. That would be somewhere over here. So only cosine and secant are positive there, so this is going to be negative. And then you should know sine is square root of 3 over 2, so this is going to be 2 over square root of 3. There we go. Plug in 10. This is just going to be sine of 10 over 10. All right. Next thing you might want to know, or something that might be helpful, would be knowing a vertical asymptote exists. With this, if you just plug in 1, you're going to get 2 over 0, so you know that there's no hole there, okay? Because if it was 0 over 0, there would be a hole. We have to do some stuff. But that doesn't give us a number. However, we know that there's a vertical asymptote, so we know that this does not exist, okay? Same thing with the next one, tangent of pi over 2. You should know that that is going to be 1 over 0, like sine over cosine. Okay, so that one does not exist. And sine of pi, remember pi's over here, so sine of pi is 0, so we get pi over 0. It does not exist. So two really quick ways, direct substitution and knowing a vertical asymptote exists. The other ones are going to be helpful, but they're going to take a little bit longer. Factor and divide out. Okay, we've already done this. We did this in the beginning of the year. Factoring, if you try direct substitution, you can't plug in 2, you're going to get 0 over 0. So you should know there's a hole there. Okay, so if we could get rid of that, somehow cancel it out. All right, we can do that in this case by factoring. These cancel out. There's a hole at 2, but now we could just take our limit as x approaches 2 and plug it into this function. So our limit is 4. Okay, plugging it in here. 1 minus 1 over 1 minus 1, 0 over 0. So you should be able to factor this. If you don't know how to factor the difference of cubes, okay, you're going to know x minus 1 is going to be a factor. You know it's going to have to cancel out. So what you can do instead of long division, in this case, is synthetic division. Hopefully you remember that. So we have 1x cubed, 0x squared, 0x minus 1. Okay, so 1 times 1, there we go, 1. 0 minus 1 is, or 0 plus 1, sorry, 1. 1, 1, 1, 0. So this is going to factor into x squared plus x plus 1. Now we can use direct substitution. Limit as x approaches 1. 1 plus 1 plus 1 gives us 3. You could do the same thing with the next problem, okay? We can factor out some things. So let's try to factor the bottom. We know that there's probably going to be a factor of x plus 1. So with the denominator, that ends up giving us 2x minus 3. I don't know the numerator. Let's divide the numerator, okay, using synthetic division. So we have 1, negative 1, negative 1, negative 3, negative 4. Great. 1, negative 1, negative 2, 2, 1, negative 1, negative 4, 4, and 0. Perfect. We know it goes evenly. So we get x cubed minus 2x plus, or 2x squared plus x minus 4. At this point, we can use direct substitution. Plug in negative 1 to these two things. Okay, and I believe we end up getting 8/5, but you should check that just to make sure. So we have 3 methods so far. Our next one is RACCON, short for rationalization conjugation. Okay, either of those will work here. If we try direct substitution, we get 0 over 0. Well, we can't factor it like last time, so we have to do something else. And one thing that we can do is multiply by the conjugate, x plus 1 plus 1. Okay, remember you need to do it to the top and the bottom, because now we're just multiplying by 1, we're not changing anything. Multiply that out, you get x plus 1 minus 1 over x times the quantity, square root of x plus 1 plus 1. Now, if you see this, we have plus 1 minus 1, they cancel out. X over x, they cancel out. So we really have 1 over that. Okay, plug in a 0, we get 1 over 1 plus 1, which is 2. You can do a similar thing here. Remember, this is that 1/2 power is just square root. Multiply by the conjugate, square root of x plus 1 plus 2, square root of x plus 1 plus 2. This is rationalizing. This is where we don't want the square root in the denominator, because if we try direct substitution, we end up getting 0 in the denominator. Can't have that. Alright, so now we have x minus 3 times the quantity, x plus 1 plus 2, all over, we get x plus 1 minus 4. So guess what? That ends up being x minus 3, which will cancel out with this, leaving us able to do direct substitution. Plug in the 3, and you get your limit value as 4. Okay, 4 great methods so far. Not too bad. This multiplying by the least common multiple of the denominator. So rewriting this one, let me get a little bit smaller pen here. There we go. All right, 1 over 2 plus x minus 1 over 2 all over x. Okay, if we plug in a 0, we're dividing by 0, we can't do that. So we need to multiply by the least common multiple of all of the denominators. In this case, it would be 2 times 2 plus x, 2 times 2 plus x. Okay, so simplifying this, we get 2, okay, minus the quantity 2 plus x. So I'm going to distribute my negative all over 2x times 2 plus x. Okay, as we simplify this in the numerator, we get negative x. And the denominator, that'll cancel out our positive x. So we'll get negative 1 over 2 times 2 plus x. Now, plug in your value. Okay, 0. So negative 1 over 2 times 2, this is going to equal negative 1/4. Alright, next one. I'm going to rewrite this one. Again, I'm going to write it smaller. So we have 1 over x plus 4 minus 1 over 4 all over x. The least common multiple will be 4 times x plus 4. Multiply that by the top and the bottom. We get 4 minus x minus 4 if you distribute that the parentheses. So we get 4x times x plus 4. Simplifying even more, we get negative 1 over 4 times x plus 4. Plug in 0, negative 1 over 16. For our next one, I would like you to go ahead and try this one for your whisk. Go ahead and write it right in there, example 5C, put your answer. Okay, you should be able to justify and show your work. Now the last one I'm going to go over, the last method I'll go over today, will be the sledgehammer, or expand and divide out and factor and cancel. So instead of saying all of that, this is the sledgehammer method. Alright, it's going to take up the most space, but it's going to be one of the quickest things. You're just going to take each term and expand it out and see what cancels. Alright, we have x squared plus 2xh plus h squared minus x squared all over h. Cross those out. Alright, great. Ooh, I can see we can factor an h out of the numerator. Divide by h. Bam, knock them out. So now we have the limit as h approaches 0 of 2x plus h. So we get 2x. Okay, last one. I'll write this out. I'm sure you can follow along. So limit as h approaches 0, x squared plus 2xh plus h squared minus 2x. This looks remarkably similar to some of the limits that we will be doing later when we get to that fancy thing called the derivative. Alright, so while I'm writing this all out, I'm sure you can find some things that'll cancel, like the x squareds, the 2x, the 1s. Oh, look, there's an h and everything left over. We have 2x plus h minus 2 all over h. Cross those out. Limit as h approaches 0 of 2x plus h minus 2 equals 2x minus 2. And we finally finished a really hard problem, so we're excited. Have a